Welcome back to Introduction to Logic. This is Lecture 4 in Unit 1, a brief introduction to induction and deduction. This is the last video for Unit 1 of Philosophy 103, An Introduction to Logic. In our previous lectures, we've defined logic as the systematic investigation into reason, or argument, and we've defined an argument as two or more statements connected by an inference. In our general introduction to logic, as a subdivision of academic philosophy, we noted that there are two main divisions within logic. Informal logic focuses on arguments whose success is determined by the quantity, quality, and clarity of the evidence expressed in the premises. Formal logic, on the other hand, is the branch of logic that focuses on arguments whose success depends on the form or structure of the argument. More simply put, in deduction, our conclusions will follow necessarily from the premises when they are organized correctly or formed correctly. More about that correct ordering in just a minute. But first, let's review the common forms or systems of formal logic. Term logic was introduced by Aristotle in the 4th century BCE and is a system that explores the relationships between the terms of formally structured propositions known as categorical propositions. Propositional or sentential logic is a system of deduction discovered and lost only to be rediscovered several times throughout the history of Western philosophy. It focuses on the logical relationships between simple propositions, which allow us to demonstrate a number of valid argument structures that will hold in all possible worlds, as well as demonstrating the difference between logical and material necessity regarding the truth of particular propositions. Predicate logic is a system of deduction that elucidates the relationships between quantifiable variables in formal systems. And modal logic is a system that helps us to understand and express the distinctions between propositions asserting modal qualities, that is, necessity and contingency, modal qualities of material and logical entities in the world. What all these systems share in common is that they are axiomatic and formal. They are systems of reason that have a finite set of rules, and those rules are demonstrable from within the set itself. Informal logic is very different from formal logic. The argumentative structures of induction are not axiomatically defined as they are in formal logic, so they're infinitely variable. But there are, as we have pointed out earlier, several common types, or we could call them families, of induction, by which we can organize the infinite variety of different inductive arguments. It is, in part, the informal nature of induction that makes it harder to analyze, as there will turn out to be almost as many ways for an inductive argument to fail as there are arguments themselves. However, it's still important for us to learn about some of the more common forms of induction, as well as the informal fallacies that affect them. This list represents the lion's share of common families of induction, which we use so often, they'll often seem second nature. And being informal, the lines between these different groups can be very fuzzy. But they again all share one common feature that binds them together under the heading induction. Their conclusions will always only follow the premises with a degree of probability, never certainty. Having now reminded ourselves of the differences between inductive and deductive arguments, we can now turn to the main topic of this video, which is evaluating the different kinds of arguments. After all, just because something is an argument doesn't mean that it's a good argument. So we need to ask ourselves, what makes an argument good or bad? Now, first we should note that this is a very poor use of terminology, since in philosophy, the terms good and bad tend to fall under the heading of ethics. They're axiological or value-based judgments. Instead, let's ask what makes an argument successful or unsuccessful. We'll introduce more technical terms for failing arguments later on. In the case of deductive arguments, it's simply a matter of whether or not they follow the rules of the particular game involved. There's one set of rules for Aristotelian arguments, there's another for propositional logic, yet another for predicate logic, and so on. But we haven't had time to learn any of those rules yet. There is, however, another way for us to begin to think about evaluating deductive arguments in the absence of knowing the specific rules. And that's because we know by definition any deductive argument that is successful is one where the conclusion should follow the premises necessarily. If in fact it does, if the premise or premises require us to accept the conclusion after we grant those premises are true, we say that that argument is valid. Let's look at a specific example to see how this might work. Remember, at this moment, we don't know any of the rules for term logic that we'll have under our belt by the end of the next unit, but we can still look at a deductive argument and make a judgment about its validity based on the definition of validity itself. Does the conclusion follow necessarily from the premises? In this syllogism, as we'll find out is true of all syllogisms, we have two premises, and we'll have one conclusion. The first premise tells us that all mammals have lungs, which happens in this case to be true. The second premise tells us that all dogs are mammals, which also happens to be true. Putting those two premises together, we must conclude that all dogs have lungs, which also happens to be true. Because the assertion of the two premises together forces us to accept the conclusion, we would judge this argument to be valid. But there's a very easy way to visualize why this is going to be the case. There are three terms in this argument: dogs, mammals, and things with lungs, which we can represent as three overlapping sets. We can visualize the first premise by shading out or eliminating the areas excluded by that premise. Since, according to the premise, there are no mammals without lungs, those parts of the set will be empty, so we've shaded them out. The second premise tells us that there are no dogs that are not also mammals, so we shade out that region as well, since it is going to be empty. We then ask ourselves if the concluding statement would have to be true, assuming that the premises are true. And we see that indeed, the only remaining things in the set of dogs are also things in the set of things that have lungs. Therefore, we must accept the conclusion, which is what makes this a valid deductive argument. The conclusion follows necessarily from the premises. But what about this case? Both of our premises are, as a matter of fact, false. Can we conclude anything from false premises? To find out, let's do a thought experiment. Just for grins and giggles, let's suppose that the premises were in fact true. Wouldn't it be the case, if the premises were true, that we could conclude that all dogs have wings? And wouldn't we have to draw that conclusion? Let's do the visualization to find out. Again, we have three terms: dogs, things with wings, and animals with tails. If we assume that the first premise is true, then there will be no tailed animals that do not have wings. That part of the set is empty, so we've shaded it out. Further, let's assume for the moment that all dogs have tails. So the region of tailless dogs is going to be empty, and so we've shaded that region out. Won't it then have to be the case that the only remaining dogs are also things that have wings? We see that it must be so. This is a valid argument. And this is a very, very important lesson that we must learn about the concept of validity. A deductive argument's validity has nothing to do with whether or not the premises are true. The only thing that matters is whether or not the structure of the argument forces us to accept the conclusion if we assume that the premises are true. So just like when we go to see a sci-fi movie, we have to begin with a teleological suspension of disbelief if we're going to accept the story, if we're going to get into the movie. The same is going to be true here for deduction. We'll worry about what's actually true later. For now, let's accept what we're given and see where it takes us. To reinforce this point, let's look at another syllogism. Here we find two premises that are, in fact, true. All dogs are mammals, and all cats are also mammals. Since there are only three terms in this argument, dogs, cats, and mammals, the only conclusion that could possibly be drawn is that all dogs are cats. The only problem is, that's not true. So in this case, we get a false conclusion from true premises, and that should never happen. To see exactly why this argument is broken in the absence of actually knowing the rules of syllogistic logic, let's go back to our diagram and visualize it. Here we have our three sets: dogs, cats, and mammals. Following the direction of the first premise, we demonstrate on the diagram that there are no non-mammalian dogs. That part of the set is empty, so we've shaded it out. Next, we add the information from the second premise by demonstrating that there aren't any non-mammalian cats. The only conclusion we can reach given the premises indicates that the only existing dogs are also cats. But what about this region? Is it populated? And what about this region? Maybe there are things in that region as well. What this diagram clearly shows us is that we are not forced to draw a conclusion at all from these premises. So even though they are true, nothing follows necessarily. This would be an invalid argument. We are not forced to accept the conclusion. As it turns out, even in the absence of knowing any of the specific rules of the different types of deduction, there is one thing that we can know, and that is a deductive argument will always be invalid if the premises are true, but the conclusion is false. In all other cases, to know whether or not an argument is valid or not requires us to learn the rules that apply to that particular game of deduction. But whenever we have true premises and a false conclusion, we will be absolutely certain that the argument is invalid. But since we haven't learned any of those rules yet, for the moment, when we want to evaluate deductive arguments, we'll simply have to settle for the only test that's currently available to us. Look at the argument and ask if the premises are true but the conclusion false. If so, we'll know for certain that it's an invalid argument. We may not know why it's invalid. We can't cite the specific rules that have been violated. We may not be able to identify what's wrong with the form of the argument, but we know that it's going to be invalid. Of course, there are going to be lots of other cases of invalid arguments as well, even ones where both the premises and conclusion are true. And as we've already seen, we can have valid arguments where both the premises and conclusion are false. What this teaches us is what makes an argument valid has nothing to do with whether or not the premises are true. So when it comes to evaluating deductive arguments, we have to begin merely by assuming that the premises are true in order to see what, if anything, follows. Of course, our evaluation of deduction doesn't end with validity. That's really only the first step. If it turns out that we have a valid argument, one where the conclusion necessarily follows from the given premises, then and only then must we go on to ask, are the premises in fact true? If we have a valid argument that also has true premises, then we will say that that argument is sound. If the argument is valid but the premises are false, we would say that the argument is unsound. We've learned that in deduction, we evaluate an argument's success based on its form or structure. If it's structured correctly, that is, if we're forced to accept the conclusion from the given premises, we call it valid. If it's formed correctly and the premises are also true, it's also going to be sound. But we use very, very different standards to evaluate inductive arguments. Remember, induction is part of informal logic, meaning the form of the argument is irrelevant to the success of the argument, so validity will never apply to inductive arguments. With induction, we expect the conclusion to follow with a degree of probability from the premises. Now, if you're thinking that that may be a little bit vague, you're absolutely right. What counts as reasonable probability is not at all exact. But again, this is informal logic, so things are going to be a bit messier than they would in formal logic. Let's say, for simplicity's sake, that 51% or higher is better than 50% or lower regarding probability. So a good inductive argument should have a conclusion which follows with a 51% or higher degree of probability. Of course, notice that I've slipped back into using my moral terminology to describe a non-moral entity, so we really need a word that's specific to the domain of logic. We can't use the word valid because that's already taken. So what can we call an inductive argument that is more successful than not? We adopt the term strong for this purpose, and this term seems particularly well suited to describe induction. Think of a bridge spanning a gorge or river or whatever. A bridge is not absolutely strong, nor does it need to be. It just needs to be strong enough, it needs to be reliable enough to get us across the gap. In fact, no matter how strong you make it, there's always the possibility that it could fail. That's also true of inductive arguments. The argument is never going to be absolutely strong. But we want the premises to be strong enough to get us to the conclusion. And just like a bridge, context is going to matter. A footbridge over a small creek doesn't need to be as strong as an interstate highway bridge over the Mississippi River. Deciding how strong is strong enough is going to require judgment on our part, which is part of what makes evaluating inductive arguments trickier than evaluating deductive arguments. Let's look at an example. Premise 1. Dogs are cute domestic mammals, and they make good pets. Premise 2. Cats are cute domestic mammals, and they make good pets. Premise 3. Pigs are cute domestic mammals and also make good pets. Therefore, cute domestic mammals make good pets. Here we have an example of a generalizing inductive argument that concludes that cute domestic animals are good as pets. Even though the idea of cuteness may be a bit ambiguous, the context helps us to understand the domain we're addressing. Of course, there are going to be cases of dogs, cats, and pigs which are bad pets, but in general, these classes of domestic animals fall within the class of cute and good as pets. If we gave more examples, we could make this argument even stronger, but the premises that we've been given in this example are strong enough to get us to the conclusion that it is more likely than not that cute domestic mammals make good pets. Now let's look at another generalizing inductive argument. Premise 1. Kangaroos are marsupials and they're cute. Premise 2. Possums are marsupials and they're cute. Premise 3. Koalas are marsupials and are cute. Conclusion: marsupials make good pets. Does the conclusion follow with a sufficient degree of probability? The answer in this case is no. There's no premise in the argument suggesting a connection between cuteness and good petness. It might turn out to be true that marsupials make great pets, but the premises of the argument are insufficient to get us to that conclusion. This argument is like a bridge that takes you halfway across the river but then just stops. It doesn't bridge the gap. This would be a weak inductive argument. So when we're evaluating inductive arguments, the first thing we must do is ask if the premises, the evidence or warrant for the conclusion, is sufficient to get us to the conclusion. If so, it's called a strong argument. If not, it's going to be weak. That leads us to the second part of our analysis. Just because we have a strong argument doesn't mean we should accept it. Just as with deduction, we also have to worry about whether or not the premises are actually true. This is the second stage of analysis. If we have a strong inductive argument and the premises are true, we label it a cogent argument. So when we're thinking about the success of an argument, if it's deductive, it will be valid and sound. If it's inductive, it will be strong and cogent. We can visualize the process of analyzing arguments, whether deductive or inductive, on a decision tree. The first step is to decide, of course, whether or not we have a deductive or inductive argument. Let's suppose, for the sake of argument, that we have a deductive argument. We then ask if the conclusion must follow if we assume that the premises are true. Remember, at this stage, we're suspending our disbelief about the premise or premises. If it turns out that the conclusion does not have to follow from the given premises, then we would say that that argument is invalid and we stop. There's no more work to be done because that argument is irreparably broken. But if we determine that the argument is valid, that is, the conclusion does indeed follow from the given premises, we go on to the next step. Are the premises actually true? If yes, then that argument is going to be a sound argument. If not, it's unsound. Also keep in mind that if the argument is sound, no matter what the conclusion is, we have to accept it, even if we don't like it. Deductive arguments that are successful, that is, properly formed with true premises, yield unavoidable conclusions. But what if our argument was inductive? Again, we start the analysis by suspending our disbelief about the premises and ask ourselves, if they are true, is it likely that the conclusion will follow? If not, we stop. No further analysis is required if you have a weak argument. But if the argument is strong, we will move on to the next stage of analysis. We ask ourselves, are the premises of this inductive argument in fact true? If not, we would say that the argument is uncogent, and we're done. But, on the other hand, if they are true, we have a cogent argument. So cogency only refers to inductive arguments, just as validity only applies to deductive arguments. It's very important to learn this terminology so we don't get confused later on. Obviously, this is the barest possible outline of how we could go about evaluating arguments. As we learn more about deduction, we'll learn the specific rules for establishing and testing validity. Similarly, we'll have time later to explore inductive arguments, and we'll talk about some of the more common forms of informal fallacies that can cause inductive arguments to be weak. But with this decision tree in mind, you have at least enough information to begin the process of evaluating the arguments you encounter, and the more practice you do, the better you will get at this. This concludes the video series for Unit 1 of Introduction to Logic. Next time, we're going to turn our attention to an examination of Aristotelian deduction, known as term logic or syllogistic logic. That will be Unit 2. So, be sure to come back for Unit 2, an Introduction to Aristotelian Deduction, as we learn a little bit more about logic. See you then.